So, okay, it's about 3 minutes after, and we're going to get started because I know everyone's pressed for time. I'm going to try to go as fast as I can and uh, uh, respect your time here. This is Glenn Broderick. I'm with Vitrek, and today's session is on metrology with basically 3 different products we're going to be focusing on. So this is my contact information. If you need to contact me in the future, feel free. Notice that everything we make is made in the USA. We're based here in Poway, which is down near San Diego. And so we manufacture, we support everything from here in Poway. Also notice that we are A2LA accredited, and that's our cert number right there in case you want to look us up. And so, let's see. So I'm going to be doing the presentation today, and like I said, we're going to respect your time. Just if you don't know who Vitrek is, we've been an industry leader in high voltage test and measurement. We've been doing this for 30 years, and we're serving over 30 countries. Our key product line is high pot testers, but we also make cable and connector testers, power analyzers, and high voltage meters. So we have one of the very few accredited high voltage labs on the West Coast. I think last I heard there's only like 3. So we're one of the very few. And so that's our expertise. And we're probably a little early for questions. I'm going to skip forward. These are the 3 products we're going to talk about today. The first one is the 4700 high voltage meter for calibrating high pots and other high voltage equipment. The second is the PA920 power analyzer for calibrating power meters and analyzers. And the third product is the 2000 Mn for calibrating DC, temperature, flow, and pressure instrumentation. Notice that you can order all of these. They come with NIST certs normally, but for about $100 or $200, we'll give you a 17025 cert traceable through A2LA. So this is our 4700 high voltage meter. You see the meter on the left, and those are our high voltage probes on the right. Notice in the very foreground, you'll see that we have a handheld probe as well. So we have a whole set of probes. This is a unique meter. It goes up to 6 digits, and I believe it's really the only high voltage meter on the market anywhere. It has a 0.03% DC basic accuracy and 0.1% true RMS accuracy. It has a rangeless design. We're going to talk more about that in a second. And people typically use this for calibrating high pots, but also any other high voltage equipment. So a lot of Cal labs use this for calibrating all of their high pots and high voltage equipment. So we can take a direct input up to 10 kV RMS and 15 kV peak. So that's just with banana jacks. And then when you go above that, then we have the high voltage probes. So calibration of probes up to 150 kV, that's RMS or peak. We don't really care which. And then one of the things the meter does is monitor voltage stability over time. Okay. So I wanted to talk a little bit about the advantage of a rangeless design. We use a different approach than most other test equipment companies. And I just want to show you that this is power across the x-axis, and this is uncertainty across the y-axis. So when you're up here in the left corner, it means you're real low power, but high uncertainty, which is not good. And so what happens is most devices have a adder for percent of range or percent of reading. And this is what you'll see, that this is how they perform. You start off with low power and the uncertainty is bad, but as the power goes up, then your uncertainty gets better and better. And then all of a sudden you have to range, and then your uncertainty gets worse again. And then you add more power and it gets better. And so this is a typical sawtooth. You see this quite often on anything that ranges meters or signal generators. Now, we have a different approach. We have a rangeless design that actually covers the entire range. And so this is an example of a curve for our PA920 using a UT card. And this is the most accurate power analyzer in the world. And what you'll see is that our uncertainty is low, even at very low powers, and that as it goes up in power, the uncertainty is still low, eventually right at the top of the range it comes up. But notice that our spec is for 24 months, and that this spec right here for this one of our competitors is a 6-month spec. So we do really a lot better. One of the nice things about this is it's a lot easier to determine your uncertainty because they're not constantly changing and all over the place. Okay. So, by the way, another advantage of this is we're really good with high crest factor signals, because other devices, if you've got a signal that varies from small to large, you would put it on a high range, and then it wouldn't be very good at measuring the low part of the signal. With ours, since there's only one range, really, it's rangeless. It doesn't really matter. It can see the small signal, it can see the large signal. It's accurate at both ends of the scale. Okay, this is everyone who attends this is going to get a set of these slides. We're going to send it out to you afterwards. And if you want to click on this, to hit Control click, it actually takes you over to YouTube and it does a quick demo. So someone just joined us and I can hear someone typing. So if you could mute your phone, I would appreciate that. Yeah, so the one trick I did notice on this PowerPoint presentation is you can't be in presentation mode. You have to put it in normal mode and then hit Control click, and it gives you a nice demo of this meter. So this is a screenshot. Basically, remember we said that the meter is typically used for calibrating high pots. There's a high pot on the bottom, and the meter's on top. And notice it's a dual use meter. It's reading both DC and AC simultaneously. So you can see the DC component and the ripple on top of that. That's one application for that. Notice that we also display the peak-to-peak voltage value and the crest factor. So again, we're very good with high crest factor signals. Yeah. The system also has the ability to plot the voltage over time. So if you have something drifting with temperature or time, then here's an example of it. In this case, the high pot put out a stair-step signal, and we're looking to see how accurate it is at each of the different levels. These are the 4700 specs. Now, these are 1-year specs, and this goes into more detail, but you know, to me, you can tell how good a manufacturer is by how detailed the specifications are. So if you look at a vendor and you look at an instrument and they don't put in much detail, a lot of times that means they don't understand all the different potential sources of error. We spec this out quite precisely. Typically for calibration, someone's playing with my system here. Typically for calibration, you would put this in the high precision mode. So that's the spec that I typically put here. We also have filters for different bandwidths. This is not a high bandwidth device. It's good up to about 600 hertz. So you would not use this in kilohertz or megahertz. This is an example of some of the probes that are available. Actually, these are all the probes that are available. Notice that we have a 35 kilovolt probe, handheld, and we've also got a benchtop probe. We've got a 70 kilovolt probe, a 100 kilovolt probe, and a 150 kilovolt probe. So, you know, whatever your application, and if you've seen the pictures of the probes, you see it's got a big ring on top. That's to reduce the corona effect. And basically, you wire your signal into that, and it's fixed, and then you step back and turn the system on. So this, except for the one handheld probe that we can use up to 35 kV, these are all kind of fixed installation probes. By the way, the probes are smart probes, so they have all the cal data directly on the probe, and that means you don't have to send the meter and the probe in together and get them cal together. You can actually just send the probe in. And what happens is when you plug the probe into the meter, it reads it and it's got the cal coefficients. The other thing is we don't pass high voltage from the probe over to the instrument. What's really passed is a digital DC signal, and that makes it safe. If you don't want to be passing around high voltage, it just increases the chances of getting shocked. Okay, any questions? If you want to unmute, you can. If you want to text to us, you can. Okay, I don't see anything, but feel free to contact us now or in the future if you have any questions on this. Yep, okay. So now we're on to the PA920 power analyzer. And so we've had a PA900 for a long time. And then we just recently, last year, brought in a PA910 and 920. The difference is that the cards that you can use with it. So the advantage of the 920 is it's got the UT card, which would be really good for metrologists because it's the most accurate power analyzer in the world. So you'll see that we have a 0.024% power accuracy. And because of the way we spec things, you don't see an adder for percent of range or percent of reading. So the other day I had someone come up to me and they said, Glenn, how do I compare this to your competitor? Because their specs look totally different than yours. And the reason is we don't have those adders. So when you see that 0.024%, that's our base spec. Now we do have some other adders for things like voltage. So if you start getting into the kilovolts, high kilovolts, there's a kilovolt square adder, and that's caused by the fact that that high voltage does a little bit of heating into the input impedance of the meter, and it warms it up just a little bit. So that's why there is a high voltage adder on there. Okay. So the UT card is good up to 1250 volts RMS. Direct input, just banana jacks, and also 32 amps RMS with an internal shunt. You can also use external shunts. So if you have your own favorite shunt, you can plug it in. We work with anything that outputs 0 to 5 or 0 to 15 volts or anything in between. And you just put in the scaling factors and we'll read out directly in amps. So this PA920 is used typically for calibrating power analyzers and watt meters. But depending on what you're calibrating, it's also good for calibrating voltage meters, current meters, phase meters, and you may want to use this for calibrating current shunts and voltage dividers. So if you've got a source with a known current, a precise known current, you plug your shunt into our device, we will read the response, and so we can see the error caused by your shunt or your voltage divider. So it's really good for quite a few different instruments in your lab. The other thing about the PA920, with one card, it can do single phase, but you can put 3 cards in there and it can do delta or Y as well, 3-phase delta or Y. Now, one of the nice things about this is it's a digital system. We digitize the signals coming through and we measure the phase. The phase is calculated as opposed to measured because it's all a digital signal. And we measure phase with a millidegree phase angle resolution. Years ago, I used to make phase angle instruments, and it was analog instrumentation. And having 5 degrees accuracy was really hard to do for an analog instrument. And worse than that, as frequency changed, the error changed over frequency. So nowadays, because of the digital equipment and the fact that our system's so precise, we can give you a millidegree phase angle resolution. And we can do it on like 19 signals simultaneously. So for instance, let's say you're looking at 3-phase signal and you're measuring power, voltage, current, and power all simultaneously. We can display that for all 3 channels simultaneously. That's 9 signals and tell you the phase angle between them. Okay. Oh, our cards are 22 or 24-bit accuracy. So if you think about a scope as 8-bit, and that means you have 256 digitizing levels. When we have 24 bits, we're actually at 4 million digitizing levels. So that's why this card is so accurate. That's one of the reasons why. Okay. So again, if you take your slides when you get them, you click on this, it'll give you a demo of the instrument. But here's a couple of screenshots. So as we mentioned, the system measures voltage, current, power, frequency, volt amp reactive, and phase angle. So right here, I'm going to start at the bottom. Here's your voltage. Remember, this is a 6-digit meter, and here's your current. And remember, this voltage and current is good from very, very small signals to very, very large signals. This is your frequency response. Here is your volt amp reactive, that is your reactive power. Here is your volt amp. This is your apparent power, and here is your true power, and here's your power factor. So those are the basics of what we measure. You can also click this little button here and put it into a detailed mode, and now it starts looking a lot more complicated. So, you know, depending on the user, if they're not sophisticated, you turn this stuff off so they don't get confused. But if you like to dig into the details, you can take a look, and now we can see watts, but we can break it into DC. What percentage of that is the DC power, and what percentage of that is AC power, as an example. Okay. Also notice down below, here's your crest factor out to 5 digits, and we can report it on the voltage. Here's the crest factor on your current as well. So this is the basic specifications, the input specification. I just wanted to show you this. So the UT card that we've been talking about for this is rated. It's rated for continuous power for 800 volts RMS. But if, let's say you want to do a quick measurement, and a 5-second measurement, turn something on, let's stabilize and measure it, we can do up to 1250 volts RMS. And then for shorter transients, we can go up to 3000 volts RMS. We are capable of measuring up to, well, I believe 2 kV direct input for short duration signals. Oh, I'm sorry, here it is, 1350 volts RMS. Okay. Notice our bandwidth is 4.5 megahertz. So, you know, just like an oscilloscope, it rolls off at 3 dB, and that means it's really flat, you know, up at 4 megahertz and above. So there is an integrated scope and signal spectrum analyzer in here as well, just to let you know. It's not full featured, but the nice thing is you don't have to double probe. It's already set up for you. It's already monitoring your voltage and current and so forth. Here is the watt error. This is the uncertainty for our system. And so the voltage is rangeless. There is one range for current, but notice it doesn't have a big impact on the overall effect. Okay, so I'm going to let you look through the slides at your leisure, and you'll notice that I've put in some of the more detailed specifications for you. Any questions? Okay. Okay, so then on to the last product. This is the 2000 Mn Calibrator. So Vitrek makes a process calibrator. It carries the Zytron brand name. Zytron originally made the product, so you may see it under Zytron or you may see it under Vitrek. But we bought Zytron's product line about a couple of years ago, and the Zytron products are all made in-house by Vitrek, and they have been for a couple of years. So the 2000 Mn Calibrator is great for verification on the factory floor. You can walk out and tie into your electronic instrumentation and verify that's working properly, or you just verify its accuracy. The military likes to use this. The Air Force has bought a lot of these. They use it on the flight line, and actually they bought many of these for the flight line. The system comes battery powered. I fly around a lot. One of the first things I had to do is check and see if I could fly with it, you know, on an airplane. It is the type of battery that they don't ban, just to let you know. We output 0 to 22 volts DC, so it's good for calibrating meters on the low range very accurately. That is our forte. It is also good. It outputs 4 to 20 milliamp for monitoring current loops, and it can it emulates thermocouples. So this confuses a lot of people. Some people, there are other like temperature baths for calibrating thermocouples. We don't calibrate the thermocouple itself, we emulate it. So what we do is we put out a voltage that looks like it's a thermocouple, and we use it to drive into your instrumentation, and that's how you calibrate your instrumentation. So we do the same thing for pressure and flow, and I'll tell you more about that in a minute. I can tell you that we are really accurate at doing this with 0.12 C thermocouple simulation accuracy, and 10 parts per million is our DC voltage accuracy, 40 parts per million is our current accuracy. So here's a comparison. I went on to the website and I took a look at Fluke, and probably the closest equivalent products are, they have a 725 process calibrator and they have a 726 precision process calibrator. And notice over here, their specs where they are 0.02%. And notice over on our specs over here, let me see, our specs, instead of 0.02%, we are 10 parts per million accuracy. So considerably better and in a similar price range. Now, we're not as full featured as the Fluke. So if you take the Fluke, it's got an integrated meter and it can do resistance. This calibrator is for a specific function, which is process cal on the floor and for checking to make sure your instrumentation is working. So we're not as full featured, but what we do a lot better, just to let you know. And so for instance, I'll give you an example. Here is their temperature accuracy. Let's say a K thermocouple is 0.8 C. And if you take a look at ours, well, I think I have that on the next slide. But it's considerably better than that. Okay. And the same, even on their precision calibrator, where we're 10 parts per million, you see they're 0.01%. So we're 10 times better, you know, in this area. Obviously, they have big benchtop calibrators. So our calibrator, you know, is in the $4,000 price range, and their benchtop can be in the $25,000 to $35,000 price range. So you can buy a whole bunch of our calibrators for the price of one of their benchtop calibrators. Let's see. So again, you can get a little demo if you just click on that when you get your slides. So this is when we emulate thermocouples, you'll see that we have about 8 different thermocouples. All the popular types of thermocouples are here. And that's the front panel of the instrument. It's very simple to use. Basically, when you get it, the only thing to know, you see how we've circled these 4 buttons. These are your enter buttons. This is your menu button. And you can go left, right, and up, down. So it's really pretty simple to use. There's a red light for charging. When you first turn it on, if that red light's on, it may want to charge for a minute or two before you actually turn the instrument on if the battery's completely dead. Otherwise, it just turns on as you'd expect. The output is right here on the front with the high and low output. On the back, there's an isothermal block, and you can put a thermocouple in the back of the instrument. Okay, here's our DC output voltages in more detail, and both for voltage and for current. And you can see that, for instance, we have a 22 millivolt range with 10 nanovolt resolution. So, you know, we get pretty good. On the current, we have a 22 microamp range, and it's got 10 picoamp resolution. So we spec things with a 24-hour, a 90-day, and a 1-year spec. And it depends on how much accuracy you need. So, you know, you choose which spec you want to use. And here's the thermocouple. So we were looking at 0.8 C when we looked at the Fluke for the accuracy. And we'll see that simulating, let's say with a K thermocouple, instead of 0.8 C, we're at 0.01 C. Okay, that's no, that's 24 hours. That's not fair. Let's put it out to 1 year. We're 0.03 C. Okay, and then for measuring on the back, for we can measure our 1 year accuracy is 0.07 C. So that gives you some detailed specifications as to our performance. Any questions? Okay, well, I hope that was helpful for you and informative for you. And we would love to open up dialogue if you have any input, if you have any questions, any ideas on how I can improve on this presentation would be welcome. And let's see, this is the company contact information on the left, my contact information on the right. And short of that, thank you very much for attending. We are done.